Hi, I'm John Etling,
I'm Trevor Riggle.
and this is the Self-Solving Rubik's Cube project. Now, this is a self-solving Rubik's Cube apparatus designed to take a series of 12 photos of each of the sides and then be able to solve it based on the design of how it works. Sorry, nothing in. Foot and mouth. All right. So it might seem a bit weird, the fact that this is a design or an apparatus that is able to solve a Rubik's Cube, which at first it is weird because that's what you buy a Rubik's Cube for, like a puzzle or a Lego design kit. You buy those so that you can build them or solve them. That in itself is the challenge. However, designing a robot to solve a Lego set or a puzzle is a bit different from getting it to solve a Rubik's Cube. And the main difference in that is that by taking the entire picture of a puzzle or a Lego set, you can put each piece individually independent of the other sides. However, for a Rubik's Cube, it's a bit different. The fact that you have to, in order to move one piece into the correct spot, you have to move other pieces out of the correct spot, increases the difficulty exponentially. In essence, this design is allowed to take a complex problem, such as solving a Rubik's Cube, gather information from the problem, and break the problem down into several simple steps in order to get to the correct ending. As far as the research for this project goes, the Otinva, saying that wrong, project or website had the project, at least the 3D parts and most of the design already up there, so that we could take most of that from there. And I'm gonna say this wrong, Popaloo was what we used for the software, and that was mainly in for the cameras and for how far to turn each of the servos of the arms that will turn each of the Rubik's Cube sides. And while those did require a bit of tinkering and a bit of hardware to get it working, it eventually was able to get a completed and working project.
So here's kind of the design of all the pieces here. So up here you have the arm, the gears, the gripper, and the slider, the legs, nuts, bolts, and whatnot. These are all from the Cura software system, and this is what I used to 3D print all the parts. Some of the longer parts, like the legs were pretty big, and these corner pieces, you had to do 8 of them for each side. Those took a while, and then like the arms, each of the arm and grippers had to be done 4 times. So it was a lot of print time, but it turned out pretty good. So the project summary, we completed the working robot, which we'll show you in the next slide, a little demo of it. It's really a hit or miss a lot of times, especially when we're still troubleshooting. One of the biggest things is the lighting. It causes a lot of hit or miss on whether it completes or not. One of the big things is like the red will sometimes look like orange and vice versa. And if you don't have the right lighting, then the camera thinks they're both the same and it messes up. Some of the problems we ran into when we built this was we were using pretty cheap wires from Amazon, and that was causing a power supply issue to the Polulu board, and we didn't realize that until we tested it here in the classroom, that the wires were actually the problem. But once we got that going, it was pretty good. So you can see here, those are all the servo wires, and then this last one is the power for the servo, and then the USB actually powers the processor on the Polulu board. And so this is mounted on the back of the camera. And you can see here, these are all the arms when it was in the building phase. And so the grippers would eventually be on each of those arms. We had to reprint a lot of the, not a lot, but some of the 3D prints to have stronger infill. A lot of the screws were, when you tighten them up, they were breaking because it wasn't strong enough infill. And same with the grippers. If the cube wasn't like in the exact position, and a gripper hit it, the gripper would just snap off. And so I had to go in and reprint those a little bit stronger, but then those were working good. And then lastly, we kind of just fine-tuned the servo motors. Since the cube is a 90-degree angle on each side, the grippers had to turn 90 degrees exactly every time too, and at the same speed and everything. And so there's a lot of fine-tuning to make sure all of those work together.
So in the future, better design choices for it will be a portable version. Admittedly, a portable Rubik's Cube solver is a bit redundant, but at least with that version, you could take it onto planes or trains or bring it on a car ride. It wouldn't be so clunky, so that we could show kids in the future that yes, we could once solve this Rubik's Cube. Another design possibility for the future is this sort of built-in Raspberry Pi touchpad, which would allow the operator to choose certain colors that they wanted to go first. So in essence, you could choose, say I want the blue to be solved first, or last, or third from the last. You could select this color to be solved at that time, and then the design would make the appropriate choices so that the blue or whatever color you chose would be solved at the time you applied. And power supply. Now the power supply is a bit, well,
yeah, so it'd be like a battery pack essentially.
Oh, that's right.
Eventually, like we would want to do like a little battery pack maybe underneath of the screen instead of just plugging into the wall. Makes it a lot more portable in that area. I think oh wait.
Oh.
Okay, that's fine.
Do you want?
Yeah, I thought it was out of order. I thought this was before the.
No.
And so here's so at first it takes 12 fixtures, 2 of each side, to make sure all the colors are right. And you see I have like little rubber bands on some of the grippers. Those kind of helped hold the cube in place without the bottom gripper. There you have it.
It's done.
And yeah, those are our sources that we mainly use for this project.
All right.
All right, thank you.
Thank you.